From Earth, there is a tiny region of the sky that appears completely empty. No brilliant stars, no colorful nebulae, and no obvious galaxies, just a dark patch that seems to contain nothing at all. For a long time, it looked like one of the most uneventful places in the night sky. Then the Hubble Space Telescope decided to stare at that darkness. Instead of looking away after a few minutes, Hubble spent days collecting the faintest traces of light arriving from that tiny area. What seemed like an empty void suddenly transformed into one of the most extraordinary views ever captured. Hidden inside that darkness were thousands of galaxies, each containing billions of stars and stretching across unimaginable distances and cosmic history. The Hubble Deep Field became one of astronomy's most iconic images. It proved that what appears empty to our eyes is actually overflowing with galaxies too faint and too distant to be seen without an incredibly powerful telescope. It changed the way humanity viewed the universe forever. Now, decades later, the James Webb Space Telescope has returned to that very same region. What it found goes far beyond simply producing a sharper image. After spending nearly 100 hours studying the identical patch of sky, Webb uncovered galaxies Hubble had completely missed. Extremely faint systems emerged from the darkness, ancient red galaxies hidden in infrared light became visible, and previously unseen structures began telling a richer story about how galaxies formed during the earliest chapters of cosmic history. This wasn't just another beautiful space photograph. It was a deeper investigation into one of the most famous locations ever observed, and with every additional hour of exposure, the darkness seemed to disappear even further. To understand why this matters so much, it's worth remembering what made the original Hubble observations so revolutionary. In 2004, astronomers released the Hubble Ultra Deep Field after combining more than 11 days of observations aimed at one incredibly small section of the sky. Years later, the Hubble Extreme Deep Field pushed those observations even further by combining multiple datasets collected over many years. The idea behind the project sounded almost unbelievable. Point one of the world's most advanced telescopes toward what appears to be absolutely nothing. Wait patiently. Gather every possible photon of light. Then see what emerges. No one expected the result to be so astonishing. Instead of emptiness, Hubble revealed an ocean of galaxies. Not a handful. Not a few hundred. Thousands. Elegant spiral galaxies, giant elliptical systems, tiny reddish smudges, distorted galaxies created by ancient collisions, and faint light that had traveled across billions of years before finally reaching Earth. It was as though astronomers had drilled a tiny hole through the darkness of space and discovered an entire hidden universe waiting behind it. What makes this achievement even more remarkable is the size of the area being observed. The extreme deep field occupies only a minuscule portion of the sky, far smaller than the apparent size of the full moon. If you held a tiny grain of sand at arm's length, it would roughly cover the same area. Yet within that microscopic window, Hubble detected nearly 10,000 distant objects, the overwhelming majority of them entire galaxies. That realization changed our understanding of the cosmos. It suggested that wherever we look deeply enough into space, galaxies are waiting to be found. But despite its incredible success, Hubble still had limitations. Its instruments were exceptionally sensitive to visible light and portions of the near-infrared spectrum, but many of the oldest and most distant galaxies remained beyond its reach. As the universe expands, light from ancient galaxies becomes stretched into longer infrared wavelengths. Thick clouds of cosmic dust can also hide enormous regions of star formation, making them nearly invisible to telescopes designed primarily for visible light. As a result, countless galaxies remained hidden. Astronomers knew there had to be more waiting beyond Hubble's vision. The question was simple. What else was still hiding inside that seemingly empty patch of sky? The James Webb Space Telescope was built to answer exactly that question. Rather than repeating Hubble's observations, Webb examined the same region with completely different eyes. Designed specifically to observe infrared light, Webb can peer through cosmic dust and detect light that has been stretched across billions of years by the expansion of the universe. That ability makes it uniquely suited for studying the earliest galaxies ever formed. For this remarkable observation, Webb combined data from two of its most advanced scientific instruments. The near-infrared camera captured extraordinarily detailed infrared images, while the mid-infrared instrument explored wavelengths completely beyond Hubble's capabilities. Working together, these instruments revealed a version of the deep field unlike anything astronomers had seen before. And the telescope didn't rush the process. Webb spent almost 100 hours collecting light from this tiny patch of sky, making it one of its deepest observations yet. In deep space astronomy, patience is everything.